610. In the diagram, the medium rectangle is made up of 10 small squares. The large square is made up of 10 medium rectangles, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So this is 100 small squares. How can you represent the large square as a power of 10? Well, if this is 10 by 10, the area would be 10 times 10, which is also 100. But we can also represent that using exponent as 10 squared. Okay. If each small square represents 10 squared, so if this one is 10 squared, then what does the medium rectangle represent? So for the medium, we know that it is 10 times the small, because there's 10 of the small. So we would have 10 squared times 10, which would be 1,000. Or we could say 10, I know that 10 to the third power, or 10 cubed, is 1,000. What about the large square? Well, the large square is 10 times more than the medium. So if the medium is 10 cubed, it's 10 times larger. So then that would be 10,000. And I know that 10,000 can be represented as 10 to the fourth power. Okay, so every time we're increasing by a power of 10. Hence why we started with 10 squared as a small, 10 cubed as the medium, and 10 to the fourth power as the large. If the medium rectangle represents 10 to the fifth, then what does the large square represent? What about the small square? Well, if this medium rectangle is 10 to the fifth, and I know this is a power of 10 greater, or this is 10 times greater, then the large would be 10 to the fifth times 10, which would be 100,000, or 10 to the sixth, because it's 1 power of 10 bigger, 10 to the fifth. There's an invisible 1 here, so then I have 6 powers of 10. The small square, well, now we're going backwards. So instead of 10 to the fifth, it's 10 times smaller. So for the small, we would have 10 to the fifth divided by 10. So that would be like saying, oh wait, this was a mistake. 10 to the fifth is 100,000. So this would be 1 million. My bad. Okay, so this would be like saying 100,000 divided by 10. So since it's 1 power of 10 less than 10 to the fifth, it would be 10 to the fourth. If the large square represents 10 to the 100th, based off of this, if the large is 10 to the 6th and the medium was 10 to the 5th and the small was 10 to the 4th, if the large square is 10 to the 100th, then this is just 1 power of 10 smaller, 1 order of magnitude smaller. So the medium would be technically 10 to the 100th divided by 10 would give you 10 to the 99th. Then the small square is saying, well, if the medium, I know the small one is 10 times smaller than the medium, but the medium is 10 to the 99th. I know we're going to divide by 10, so it's going to leave me with 10 to the 98th power. So when we're increasing by a power of 10, our exponent grows by 1. When we're decreasing by a power of 10 or dividing by a power of 10, our exponent decreases by 1. Okay, so complete the table to explore patterns in the exponents with multiplying powers of 10. You may skip a single box in the table, but if you do, be Okay, so here I see 10 squared is 10 times 10. That's where that's represented. And 10 cubed is 10 times 10 times 10. When I write it with a single power of 10, that becomes 10 to the 5th. So here I have 10 to the 4th times 10 cubed, so I have 10 times 10 times 10 times 10. If I have to write it, you do 2 times 10 times 10 times 10. Knowing what I know about exponents, I have 1, 2, 3, 4, 5, 6, 7. So 10 to the 7th power. Okay, 10 to the 4th times 10 to the 4th, 10 times 10 times 10 times 10, 10 times 10 times 10 times 10. My base is going to be 10. My exponent is going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, here I have one group 10 times 10 times 10. I know that's 10 cubed, or 10 to the 3rd power, and 10, 1, 2, 3, 4, 5, and 10 to the 5th power. I know my base is going to be 10, so I have 1, 2, 3, 4, 5, 6, 7, 8. So also 10 to the 8th power. 10 to the 18th times 10 to the 23rd, 10 times 10 times 10 times 10 times 10 times 10. Oh, wait! We can skip it. Good thing I saved it. Skip! No, thank you. But can we still figure out what the power of 10 here is? Let's see. We know the base will be 10. So up here it said 10 squared times 10 cubed. My exponent was 2, my exponent was 3, and my exponent is 5. 4, 3, 7. 4 plus 4 is 8. Oh, 3 plus 5 is 8. I think I can just add the exponents because the exponent is representing every power of 10. So 18 plus 23, 41. So I think it's to the power of 41. If you chose to skip one entry in the table, which entry did you skip? Why? The middle box of the last row because ain't nobody got time for that. Because that would be a lot of writing and time. Okay, it's really just not efficient. That's why we have exponents, to help us be more efficient. Because if you're going to be here writing 10 times 10 times 10 times 10 times 10 41 times, you need to get away. Just kidding. Part C says, enter 10 to the 4th times 10 to the 4th into your calculator to confirm your answer. Describe the answer that the calculator provides. So I need a calculator. Here, I'll just use phone. So, calculator 10 to the 4th times 10 to the 4th, 10 to the 4th times 10 to the 4th, 100 million. Okay. I think it expresses the answer this way because 10 to the 4th times 10 to the 4th is 100 million. Enter 10 to the 18th times 10 to the 23rd, 10 to the 18th times 10 to the 23rd. It says 1E41. Why do we think it does it that way? Oops. Really, that would, because it's a really, really big number.
But on our calculators, it shows 1 times 10 to the 41th power. So it is a little bit different if you're on your phone or a calculator.
So if we notice, this was the same problem as before, and we were right with our exponent because this is saying to the power of 41. So 10 to the 41. So how do you think it would display 10 to the 98? I think it would be the same. 1e to the 98th power. Use the patterns you found in the table to rewrite 10n times 10m as an equivalent expression with a single exponent, like 10 to the whatever. So up here, what did we do with our exponents to get it as a single power? Since the bases were both the same, what were we able to do with our exponents? Okay, so exactly, we could go 10 to the n plus m power. Oops, I need to zoom out, sorry guys. We go to the 10 to the n plus m power because up here, when we had the same base, we were able to just add the exponents. Okay, use your rule to write 10 to the 4th times 10 to the 0 with a single exponent. What does this tell you about the value of 10 to the 0? So 10 to the 4th plus 0 equals 10 to the 4th. So I noticed that I started with 10 to the 4th and I ended with 10 to the 4th. So the 10 to the 0, so 10 to the 0 power would have to be equivalent to 1 because anything times 1 is itself. So 10 to the 4th times 1 is itself. 10 to the 4th times 10 to the 0 is itself. So 10 to the 0 has to equal 1. We'll explore that more in depth later. Okay, so here's our summary. In this lesson, we developed a rule for multiplying powers of 10. Multiplying powers of 10 corresponds to adding the exponents together. To see this, you multiply 10 to the 5th and 10 squared. We know that 10 to the 5th has 5 factors that are 10, and 10 squared has 2 factors that are 10. That means that 10 to the 5th times 10 squared has 7 factors that are 10. And here's the expanded form, 10 times 10 times 10 times 10 times 10. That represents this part, and 10 squared is represented here. So together, you get 10 to the 7th. This will work for other powers of 10 too. So 10 to the 14th times 10 to the 47th is 10 to the 61st power. This rule makes it easier to understand and work with expressions that have exponents. We're talking about efficiency. You don't want to write 10 times 10 61 times. Let's look at the problem set number 1. Write each expression with a single exponent. I'm going to do a couple with you, and then you're going to be left on your own to finish. So, number 1, 10 to the 3rd times 10 to the 9th. Well, I know I can go 10 to the 3 plus 9, which is 10 to the 9, 10, 11, 12th power. B, you want to be careful because since there's no exponent, there's really an imaginary 1 because 10 is the same as 10 to the power of 1. It's just itself. So you get 10 to the 1st plus 4th power, so you get 10 to the 5th. The same applies for the rest. F looks tricky, but it's still the same idea because you're multiplying and they all have the same base of 10. So you get 10 to the something power. Okay? That's that. Have a great day, guys.